And I'm asked to find the velocity of the wave. What is the wavelength here? What's the wavelength? The top graph. 0.0032 meters. Yeah, make sure to convert back to base units. If you wanted to, I probably would have just written 3.2 times 10 to the negative third meters. Really means times 10 to the negative third, right? Whether you jump the decimal or whether you just slap on the scientific notation, it does not matter. Please use correct base units. When in doubt about them, put up your packet, right? The packet actually has a sheet in there that tells you what each thing is worth. It says milli, and then over to the side it'll say 10 to the negative 3. All right, so you just open it up, look at it, slap it on. On the quiz, we had lots of mistakes. I wrote centi right here, put centi, and lots of people left it as is. Didn't convert it all. Many others of you converted incorrectly. You put like 4.5 centimeters was just 0.45 meters. Try again, right? 4.5 centimeters is right there, right? That is not the same as 0.45 meters, right? Big difference, big difference there. So be careful with that. Period. Now, period might be a little tough here because I don't show you the period on this graph, right? I show you what 3/4 of the wave is. I show you that 0.75 is to 4.9 as 1 is to x. Does that make sense to everybody? I'm going to set up a ratio to solve the whole period. So, would you find the period to come out to be, please? Unit. Nanoseconds here. And since this isn't the final answer, we need to all see this. You good so far? Yes. Awesome. Alright, now we got to solve the velocity. From up top, remember velocity equals lambda f, or velocity equals lambda divided by the period, right? Because frequency is 1 over the period. Please keep frequency and period straight in your head. Whenever you're dealing with this equation, another common mistake of the quiz is we tried to integrate in angular frequency. We wanted to put it in there so bad. We couldn't help ourselves. Had to figure out a way to squeeze in angular frequency. This has nothing to do with angular frequency. There is no omega in this equation, right? No need for it. So don't squeeze it in here whenever you don't need it. So now V is going to equal 3.2, excuse me. Let's try that again. 3.2 times 10 to the negative third divided by 6.53 times 10 to the nano means what? Negative 9. Negative 9. What's that velocity come out to be? Come out in the order of what? Negative 7? No, excuse me, not negative 7. Positive. 4.5 times 10 to the... Is that what the rest of you got? 4.9 times 10 to the 5th. I'm sorry. Times 10 to the 5th. 4.9, 5.2, so approximately 5.0 times 10 to the 5th units. Meters per second. Yeah. Is that a reasonable possible answer? Yes. Yes. What would be a example of a non-reasonable answer? Times 10 to the what? Negative 2 would be a little weird, possible, right? Nanoseconds here, we're traveling a distance in millimeters and nanoseconds. That means this wave's going pretty fast. All right, if you think about it, going 1 millimeter in 1 millisecond will give you a velocity of 1, right? Give you a velocity of 1. So we're going farther distance in less seconds, right? This has to be something big. How about something times 10 to the 10th? No, why not? It's faster than light. We ain't going faster than light. Okay? Can't happen. Right? So if you get anything above 3.0 times 10 to the 8th, it's not reasonable. Now, don't freak out if you get that. Check the next question. The next question might read something along the lines of, is this answer possible? Right? Or does this wave actually exist? So you come out with 7.9 times 10 to the 10th meters per second. Right? Look at the next question, see if it reads, is this feasible? Right? Or is this wave possible? Does it actually exist? Then you can write no, it's faster than speed of light, blah, blah, blah. Questions? There is none. Next. Okay. Wavelength of light, 30 nanometers. So basically what I have right here is I got a picture like this. I have down here is glass, right? Up here is air. There's a normal. Light comes in, strikes at a 29-degree angle to the normal. 29 degrees, and then it's going to refract. The question is, first, what's theta 2, right? And then secondly, they tell you the wavelength of light coming in was 330 nanometers. What's lambda? Did everybody kind of get that set up there for it? Yeah? All right. So what equation do I want here to find theta 2? Yeah, that part of Snell's law thing, right? And it goes to flow chug. All the angles are already given to you measured from the normal. That would be the trick if an angle was measured from some other place besides the normal. If the angle given to you was measured from there, the surface, you'd have to do 9 minus that angle to get to the angle measured to the normal. You have to use angles measured to the normal to plug in the Snell's law. Okay, otherwise this is all off. So this is 1 over 1.5 equals sine theta 2 over sine of 29. What's theta 2, please? $18.9. 18.9 degrees. Let's look at our sig figs. Looks like we get 2 of them, so this becomes 19. 19 degrees, which should make sense to you. I said whenever you're going into a medium, the higher refractive index, the angle is going to bend towards the normal. The angle is going to shrink. Okay, the angle is going to shrink. Then for the next one, define wavelength. What equation do I want to use? All right, N1 over N2 equals what? All right, so V2 over V1. Whenever it goes into a new medium, it changes velocities. Right, speed of light changes velocities, which also means those of you who are thinking a little bit farther down the road in physics, that means that relativity changes based upon the medium that we're talking about. Right, because nothing can go faster than the speed of light. The speed of light changes based upon the medium. Right, so where general relativity comes in depends upon what stuff you're in. Kind of an interesting thought. So that's N1 over N2 equals lambda 1 over F divided by lambda 2 over F. Right, velocity with wavelength times frequency. Frequency of light does not change. So what happens to the two frequencies? Good. Cancel. Right, leaving me with 1 over 1.5. Oh, yes, thank you. Good catch. 2 over 1. 1 over 1.5 equals lambda 2 over lambda 1, right, which I said was 330, correct? Now, when in doubt, convert back to base units. Since there are no other units in here, I can leave this in nanometers, and my answer will come out in nanometers. Okay, but when in doubt, if you were struggling with this thought, put 330 times 10 to the negative 9. So 1 over 1.5 times 330 nanometers gives me what? 2.2 times 10 to the 7, so 220 nanometers. 220 nanometers. We haven't talked about this with shifts yet. We're going to get to that with we're going to get to that with Doppler effect, because you talk more about shifts with Doppler effect. Whenever the wavelength of light goes down, this would be called a blue shift. A blue shift. Okay. The wavelength of light went down, it shifted more towards the blue side. Okay.